Okay. I'm going to flash back to yesterday's, whoa. I tried to blow it up a little bit. Let me make sure I'm still in that mode. Hold on. Yeah. Okay. Yesterday's exit ticket is a good example of what we were doing yesterday. Okay. And after yesterday, it didn't happen so much in here, but yesterday in the second period, in the afternoon, I had some folks that, either while the exit ticket was going on or right after, it was like, what? I need help. That was so hard. I just kept hearing all these comments, and I was like, we didn't hear those in first period. So you know what? We'll just use this as one to talk about. Sometimes, with the exit ticket, we don't really get a chance to go back over it. You do get the feedback. How many of you on the exit ticket yesterday, you got all the points? Okay. How many of you just missed one? Okay. And so I can tell just by asking those two questions, it wasn't our best exit ticket. And I didn't figure, with something like this, and it was brand new yesterday, it might not be our, we might not be great at it yet. So let's just look at it. All right. So all this information up here is telling you what you can already see. It's just letting you know how big some of the angles are that they have told you. Okay. Remember I said yesterday, when you have something like this, you have to go in and pull out what you already know, because there are things there that you know that they've given to you, and then there's things, of course, that you don't know. Now, this is what we don't know. Those are the three things they want us to figure out, right? Okay. We need to know what angle K is. Let me get a pen here. And angle K is down here. Let's just trace that with, we need to know that angle. We need to know angle M, which is here. Make it a different color. And we need to know angle N, which is here. And so, okay, how can I figure out those three with what they've already given me, plus what I already know? What my noggin has up here for my common sense, my reasoning, okay? All right, so what do we already know? What is something we know for sure? Yeah.
36.
Okay, they've given us this one. I'll draw it just a little bit bigger. This one is 36 degrees. Okay, what else? Yeah, that box, we've got to know what that box means. That box in the corner means 90 degrees, and y'all have gotten really good at recognizing that. I remember a year or two ago, we had problems like this, and I would have somebody stare at one of these figures forever and forgetting what that box meant. And they're like, I just don't have enough information. Yes, you do. It's there. What are they telling you? Not with a number, but with that little symbol. Okay? So we know these two. All right. There's something else there that we know that is not a number, that is going to be helpful. What is it?
The 36-degree angle, the opposite of it is K, and that's 36.
Okay, that's one bit of information that's important. And then there's some others too that maybe you could keep looking, because there's lots to pull out of this. All right, what Will is telling us is that rule that we learned yesterday. If you have intersecting lines, the opposite angles are equal to each other. Okay, so this and this, those are opposite each other, the 36-degree angle and K. So if that's true, then I know this is 36. This and this would have to be the same amount. Okay, so we've already found one of ours, and that was pretty simple. That was just because of a rule. That really wasn't because of any math problem we had to work out. Okay, what else do I already know about lines, angles, and lines? Why does Miss Wendy have us do all this all the time? What else could be helpful here?
Because of the 180, how it's a straight line, and you have 36 and 90, just add those together and then subtract it from 180, and then that's the missing piece for M.
Most, I would say most, I think that's probably safe. Most figures you look at like this are going somewhere in there. They're going to have a straight line, And we know that straight angle, that straight line angle is 180 degrees. We just need to know that, okay? So if all of this, here, I'm going to make this arc really huge, okay? If all of this is 180, and I have two of the pieces already, then I can figure out the missing one, right? We did that several days ago. So 90 and 36 and M make 180 together. So let's put 90 and 36 together first, okay? Some of you might can do that in your head, but I feel safer doing that. 126. So that's what these two pieces are. Don't add that and think that's M. Not yet. Okay. How do I know without doing any more math that M? You know, what if I was in a hurry and I put these together and I went, oh, that's M. How do I know with my noggin here that M cannot be 126? We've got to use that reasoning. Bailey, why? Okay. This plus that, you know, I mean, I said that wrong. Well, M doesn't have to equal 180. It does have to equal 180 altogether. But what's something else? Keep looking at it. Keep looking at it. Yeah. Okay, it's an acute angle. So it's got to be smaller than 90, and that's way bigger. Okay? Do what? All right, what's my step that's left, though? What do I need to do? Yeah.
Subtract 126 from 180.
Okay. Because I know this whole thing is 180, I'm going to subtract those two pieces, which is 126. Now, that looks like that fits that angle much more. We know 54, that's an acute angle. So this is 54 degrees. So M is one of our things we don't know. We're going to come and put it back, you know, put it up here as well. Okay. So we've got one angle missing, and there's more than one way to figure it out. Will, what's one way? Okay. All right, do y'all see that? All right, look closely. You see angle N's pretty big, right? It's obtuse. It is opposite this over here, isn't it? Together. Okay? Look at this very carefully right here. All of this angle, can y'all see that? N is opposite these two angles together. So if I put 90 and 54 together, that would equal N. That's one way to get there. All right, I want you've got to start looking at these figures kind of from all directions. You see that straight line that we traced a minute ago? Let me go back over and trace it one more time because I've got a lot going on up here. All right, watch. Here's a straight line, right? If it's a straight line for the things above it, it's also a straight line for the things below it. So everything, I don't have a lot of colors to choose from, and I'll make it red. Everything right here is 180 degrees, right? So I have one piece of the 180, 36. So can't I do 180 minus 36 and find that other piece? Yeah. So that's what's kind of fun about geometry is you can look at it from a lot of different directions. You know, don't let it overwhelm you. If you're not seeing everything we're saying right now, I think you will. Just the more we practice with these kinds of things. So we could do 180 because there's 180 degrees right here in red. We could subtract 36, and when we do, we'll get N, which is our missing piece here. All right, I've got to remember to bring that 1 down because if I forgot to bring that 1 down and I go, oh, it's 44 degrees, and I come over here, 44 is acute, and that's a really, what kind of angle is that?
Obtuse.
It is obtuse for sure, so 144 is what N is. Will, what do you want to say?
There's 2 right angles in there, and that whole thing, because 54 plus 36 equals 9.
Okay. those two together would be a right angle.
Yeah.
So, like, these two pieces have to equal 90 because 90 and 90 have to be 180. There's a lot of stuff in there that you could keep pulling out like that. Okay. All right. So I know that was a big problem to take on as our exit ticket yesterday, and I just want you to try it. I just wanted you to see what you could do with it. Okay. But maybe seeing it one more time today will help us. Maybe not, but maybe so. Now, I'm going to tell you about today, okay? Today we are jumping into something totally different. Today is going to feel like we've taken a break from everything and gone to just another kind of math, My things are not in order. There we go. All right. So, let me get it up here where you can see it good. Actually, probably just going to switch to some space. We will need some space. Do I have things to throw away here? Yep.
Erase it, just erase it.
Is that what I need to do? Because I feel like I've done that like 3 times now. I feel like I've gotten rid of it like 3 times. Paisley knows this way to clear out the board so that things won't keep popping up. I don't know if y'all, we're going to have to figure that out. Y'all remind me in the afternoon and she can teach us. Okay. So, I'm going to start us off with something we're just going to do. And then in a few minutes, we'll talk more about what it is we're actually doing. Okay? So, I need to put something in your hands. Not my sticky notes. Okay. All right, so all I have right here is a construction paper square. Okay, that's all it is. And let me put it in front of you so we can start using it. Okay. All right, so what you have in front of you is a square. Yes? Okay. What I want you to do is for just a minute, I want you to try and fold this so that, listen to all your directions here, so that both sides are exactly the same. Kind of like one side would be looking in the mirror at itself at the other. Okay? Okay. Can you fold this so that both sides are exactly the same? Go ahead and try. And when you open it back, like you'll fold it, but when you open it back up, both sides look the same. They're like mirror images of each other. All right, so once you do that, once you think you've done that, open it back up and see.
What if one's just a little bit bigger?
Okay, then that's not it. Okay. So what I've just witnessed or watched you do is this. Some of you went from the top to the bottom. Some of you went from side to side, but you took 2 corners and put them over on top of the other 2 corners, right? And you do have to kind of pause and make sure before you make that crease, don't you? So that we don't have the situation of one side bigger than the other. So it's not always easy to get them just so, you know? All right. So Have we done it? Open it up. Do both sides look the same? Now, I know that we're not machines and we're not a computer and we're not 100% exact, but we're pretty close, aren't we? Is there, so you created a line, haven't you? Okay, could you take your pencil out and trace that line? Just that one line that you just made, that fold line. Okay, alright, just lay your pencil down. Okay, guys, if we're working together, zoop, done. Okay. Is there another way to fold this so that both sides, so that, you know, we've got the one line. So in other words, I don't want you to fold it on that same line, that same direction anymore. Is there another way to fold this so that we can create another line? So if you think there is, go ahead and do it. Go ahead and do it. Okay. Do it the way you think it needs to be done. Alright, so I don't really want to know how you did it. I just want to know, thumbs up, thumbs down. Did you find another way? Yes? No? I'm not sure. Okay. Alright, so alright, go ahead, if you did, trace that line. Is there another way? Okay, if you think there is, hold it. Okay, we're sitting down. You better not do anything. Now, but when you open it up, only trace that line if both sides, the way you folded it that time, you know, are the same. But if they are, trace that line. Listen to me. Lay your pencil and your piece of paper down, but your piece of paper open all the way up so you can see it. Okay. All right, so here's your next task here. I'm going to hand you another piece of paper. Okay, just lay it down right now. I'm going to hand you a different shape. Okay. And in just a second, well, let me hand it to you. Don't do anything to it, okay? Just look at it because it's so pretty.
Yeah.
Okay, right now everything's down. Okay. You know what we just did with this square, right? Okay. In just a second, I want you to take both pieces of paper. You'll need your pencil also, I guess. And you are going to go somewhere, and then in just a second when you get there, listen to what you need to do. I need you to pay attention. Okay. You're going to try the same thing with this. Are there different ways that you can fold this so that when I open it up, both sides are exactly the same? But the thing is, I don't know if everybody finished their square. So I want you to have a discussion. Is my square folded as many times as it can be, or am I missing any? How many times can I fold my rectangle so that both sides are exactly the same? Now when you make the fold and you open it back up and both sides are exactly the same, you do need to trace that fold line so that you can see it, and then if you move on to another fold, that first one is still there, okay, so that we don't forget about it. Okay, so I want you to take your square and rectangle, your pencil, go stand at someone else's desk, master on, and I'm going to give you a couple of minutes to work on, finish your square if it's not, and do your rectangle. I'm not sure if we are even today. We are even today, so everybody should have one person to work with. Okay, we don't need furniture. Y'all can stand. Let's put those up under the table where they go. Talk about with each other. If somebody is doing it wrong, like they folded it, but both sides are not the same, then explain that in a kind, respectful way. Okay. Trace your fold lines. But when you open it, both sides have got to look the same, like a mirror image. Alright, we got another minute.
Wait, maybe if we have it on
Alright, so in 5, 4, 3, 2, and 1, if you would go back to your seat. so you have your shapes, your pencil in front of you. Please open them all the way up. Okay? Lay your pencil down. Okay, your shapes are opened up, your pencil is down. And so I just want to talk for a minute about what did you find. Okay? All right. Did you find them all? Look at your square. Your pencils are down right now. Look at your square. How many ways were there to fold the square? Raise your hand if you figured it out. How many, Kennedy? 4? How many of you found 4 times with your square? Okay, right now the pencils are down. I'm giving that direction about 4 times. Okay. How many of you found 4 ways to fold your square? Raise your hand if you did. How many of you found less than that? How many of you found more than that? Okay, there were only 4 ways to fold the square where both sides were the same. Okay, there was, please, pencils are down, your eyes are up here. Corner to corner. Yes, we started off that way. We drew that line. The other corners. Okay. And then, how else could I fold it? Yep. Into a, what would it look like once a triangle? Okay, that way. And then the other 2 corners, a triangle. Okay. Alright. If you found more than 4, there were 4 lines that were traced. Or should have been. Okay? If you found more than that, how did you do it? Yeah.
I did like what you did first.
Okay, but it can only be 1 fold at a time. So did you keep folding? Okay. All right. And you know what? Now it's not sometimes until the moment something happens that I have a flashback from last year, and I remember this happening, and having to say, because I'm clear in my head what I want you to do, but if I don't say it, you might not be clear. So I never said you couldn't fold it more than once at a time, did I? I never said that, and so please keep that in mind today. When we're talking about making these folds, we're not watch me, because one year somebody was like, it was like origami, and somebody was making shapes and all kinds of things. When we're talking about making that fold, we're talking about 1 fold at a time. So I did not need you to fold it and then go and keep going. It's just 1 fold at a time. Because what we're doing in that 1 fold is creating a line across our shape. So I didn't explain that well enough. Okay. Questions about the square? Questions about how to fold it? Okay. All right. So moving to your rectangle. Now this is just a piece of construction paper, but it is a rectangle. How many ways were there to fold the rectangle? Yeah. Anybody get just 2? Anybody get more than 2? Okay, now again, we're talking about 1 fold at a time. Okay, because if I fold it, and then I fold it again, and I fold it again, when I open it up, where's my line, my 1 line across the whole shape? Okay, so please, if you've done that, open your shape up, because you don't need to see it folded multiple times. That's gonna confuse you for what we're doing today. Okay. Could the rectangle be folded the same way as the square? Sometimes. I'm seeing yes and no, and you're both correct. Sometimes it could. Could I fold it like that at first? Yeah, that worked. When I opened it up, both sides are the same. Could I fold it down? Yeah. If I open that up. Both of these are a mirror image to each other, but could I go from corner to corner like this?
No, because it's not full space.
Well, you can even see it happening. When I do that with the square, everything on the top laid right on top of everything on the bottom. But when I do that with the rectangle, we've got pieces sticking out. You see that? You probably saw it. You might have seen it happen at your desk. Okay. So these don't match, do they, when we fold it? With what we're creating, guys, is called a line of symmetry. A line of symmetry is a line that goes through an object, a shape. It doesn't have to be just a shape. It could be something we see in regular everyday life. And when that line goes through it, if I folded those two pieces up, both sides would be exactly the same. Okay? There's an animal in nature, and there's a really good chance you've heard of this and heard about it and how it's created. But the way it was created, when it naturally folds itself up and opens, and that's what makes it fly. But when it's open up, it completely matches on both sides. You know what I'm talking about? Yeah. That one, huh? A butterfly. A butterfly's wings. The patterns on butterflies' wings are exactly a mirror image of each other. If I just had half of the butterfly, but I held it sideways up by a mirror, it would look like the whole thing was there because I could see both sides of it exactly the same. Okay. So these are called lines of symmetry that we can draw through something and both sides match. Symmetry. Something is, you ever heard somebody use the word symmetrical? Okay. If I say, hey, both sides of that are symmetrical, I'm telling you both sides look, they match, they look the same. Okay. All right. So, in the square, we found 4 lines of symmetry. In the rectangle, only 2. Some shapes are not going to have any at all. Some shapes are going to have so many that they're all hard to find. Okay. All right, so let's keep going. The more we talk about this, the more you see what we're talking about. All right, let me move to this. Now, I'm not, every shape that we talk about today, I'm not going to hand you, okay? But some we will, some we won't. Now, look at these 2 shapes. There's a parallelogram and a rhombus. How many of you remember talking about these shapes last year? Did you talk about them in class last year? Okay. This is one of the things that sometimes happens at the end of the year, and I'm not sure how much you got to. So maybe you did, at least a little bit. Okay. May not remember it. Okay. Anyway, very similar in shape, but let's look at them. Everything's out of your hands right now. Okay. Push it up to the top of your desk. There you go. All right, so kind of looks like the shape of Tennessee, doesn't it? All right, so to match that, it's a little more this way. Now, how many lines of symmetry do we think a parallelogram might have? 4. I think this one has 4. Anybody have a different number? Anybody agree with 4? Okay, which way should I fold it to? Now, this is one where we're just going to talk about and watch. Okay, which way should I fold it?
Fold the points down together.
Here?
Uh-huh.
All right, so if I put these points together, will both sides match? Let's look and see. Are they?
No.
They're not. Okay. Good suggestion. Any other suggestions? Is there another way to try this? What do you think?
The way I was thinking, I don't think it works like fold it down, but I think the corners have to be
Like down, top to bottom?
That's how it
Okay, but we can look at it. If we go top to bottom, like this, line it up at the bottom, what's happening now?
The pieces stick off.
It's kind of hanging off on the sides, isn't it? Okay, so top to bottom is not going to work. Diagonal is not going to work. Yeah.
There's no way to do it. There's no way to see it.
I mean, if I do those other points this way, maybe you're thinking maybe, just maybe, but it's not, We didn't go sideways, so side to side. Yeah, that's way off. You can almost see it. Can you picture the fold in your head? Like picture, because you don't have it in your hands, and sometimes you have to look at a shape on a workbook page or on a picture up here. In a minute, we're going to talk a lot about some shapes that we're all just going to be looking at. I'm not going to have one in my hand either. And so you kind of have to picture the fold happening. If I did this, what would happen? Would both sides match? And you're right, there's not one here, okay? And so rhombus, is it going to be really any different? It's just a smaller version, isn't it? Okay? And so let's keep moving from there. What about this shape right here? This is a trapezoid. Okay, now and the word trapezoid's hanging off a little bit, so that's what you see on that line right there. I want you to just look at the trapezoid for a minute, okay? And I want you to try and picture in your mind, is there any way, this is kind of giving us practice, folding it mentally, okay? Is there a way to fold that where both sides would be the same? I want everybody looking at it. Okay? And picture yourself taking it from corner to corner or side to side or top to bottom or the other corners. But look at it. I will tell you this. It does have a line of symmetry. It may have more than one. Okay? So I want you to find it. I want you to find it mentally without having it in your hand to fold. Okay? Jayla, what are you thinking? Say it one more time. Like side to side. Okay. I cut one a minute ago. This one's a little taller. Okay. But if I took one side and I folded it over to the other side, does it match? Mm-hmm. It does. So going sideways with this, because at first you might look at this and be going corner to corner and, and you can find lots of ways a shape won't work as well as you can find a lot of ways it will work. So that definitely is, and let's draw it up here. Sometimes, guys, you're going to be asked to draw the shape itself. Sometimes you're going to be asked to draw the line of symmetry. So if you're asked to draw a line of symmetry and they give you a shape like this, they want you to, sometimes I call cutting it. Take your pencil, cut that shape where you think a line of symmetry is. Well, what Jayla just said is it would be right here. You can draw a dotted line or you can draw a solid line. Now, is my line 100% perfect? No. What I don't want to do is this. Okay, there we go. See what I'm saying? Now, I know when I draw my line, it's not 100% straight. It's not 100% perfect, but I can get better than that, can't I? I can go closer than that.
It's like super close.
Well, and if I fold it right there, is it going to match? No. But I'm going to get closer and go right here. Again, I know I'm wiggling. We're not perfect. We move a little bit. We're not a machine or something. But there's our line of symmetry. Is there any more? Sometimes we find, this is what happens a lot. We find one. There's one. And that's a good one. But then we stop and we don't try to find any more. And sometimes there's a whole bunch more that we need to look for. Is there any more in the trapezoid?
No.
Can you mentally fold it? And sometimes it's hard to think of another one when there's one already drawn there. But can you think of another way? Anybody want me to try it a different way? Can't you see in your mind that won't work? Yeah. All right. If you were thinking corner to corner, look at this side of it. It's not going to work. And the other side would be very similar. Okay. But yeah, this trapezoid has that one line of symmetry right through the middle like that. Okay. I'm going to put another shape in your hand. Okay, and please don't do anything with it yet. Alright, don't do anything with it yet, please. Alright, so you have a circle. Alright, what I want you to do in just a second is we're going to do the same thing now. Don't do it yet. You'll know when you're supposed to start trying to fold it. You are going to try to fold this and try to find a line of symmetry. Now listen guys, it's one fold. Open it back up. It's not fold it down, fold it, make it really small. It's one fold, open it back up just like this. It's another fold, open it. It's one fold at a time. Does that make sense now? Not, I need to go right now and write that in my teacher book really big because we have this happen every year and I forget to write it down because it happens right in the middle of the lesson. When you find a line that works, that's why you open it back all the way back flat because you're going to find that line and because you're cutting across the entire shape when you do that. So trace that line, okay? All right, you're going to go back where you were for just a second. So you'll need your circle only. Okay, I need you to stop moving. Your circle, your pencil. So every time you and your partner find, it might not be like if I was working with Gage, he might be folding his one way. I might be folding mine a little different. His and mine don't have to match exactly, but I might help him find what I found, and he might help me find what I found. What do you think? Okay. All right. Give you a couple minutes to do that. Go back where you were with your circle and your pencil. Find as many lines of symmetry as you can. I'll set the timer this time. Both sides need to be mirror images, exactly the same. Okay, let me make this quick announcement. Can everybody just freeze where you are for 2 seconds? They're working on something in the gym. Whatever they're working on might set off the fire alarm. I said if that happens, just ignore it. So, okay.
There's 2 ways. This one.
About a minute left. Okay. Can't fold it that way, can you? That's 2 folds. One fold at a time. Open it back up. Okay. Cannot do this. All right. Okay. One fold, open it back up. One fold, open it back up. Do that. Trace every fold. Alright, make your way back to yours. So you should be finished. Maybe. Okay. Please look at me. Please look at me. This is okay. This, not okay. Please don't do that and call it a fold. We just said you can't do that. That's 2 folds, isn't it? Okay. 1 fold at a time. Open it back up, draw the line. Try another fold, try another direction. If you find a line, open it up, draw the line. Now, let me ask, how many lines of symmetry were you able to find? What did you find? 2? Okay. What did you find? 8? What did you find? 4? 4? Anybody else have a different number? We've got 2, we've got 4, we've got 8. Okay. I'm going to say you're all wrong. Okay. Even though I know that you found 3. Okay. Now, are the lines of symmetry that you found correct? Well, show me what you found. How did you fold it? Show me one of them. What did you do? Just like in half? Okay. Okay, but you can't do that. You can't. 1 fold, open it back up. This, guys, right here does not cut across the whole shape. That's 1/4 of the shape. That line right there cuts across the whole shape. Okay? All right, so you folded it that way. That works. Open it back up. Draw that line. What did you find? Okay, hold on. One at a time. Down. That's another one. Open it back up. Draw that line. Okay. What was another direction? Anybody find it differently? Go ahead. Diagonal. Open it up. Draw that line. Diagonal the other way. Diagonal the other way. Open it up. Draw that line. You know why you're all wrong? You're right, and yet you're wrong. All of those, how many of you found all of those, or at least some of those? You folded it down, you folded it sideways, you folded it diagonal. Okay, those are all correct. But the thing with a circle, you see all those spaces in between that don't have fold lines? There's one everywhere. There is an infinite number of lines of symmetry with a circle. Okay. You could keep going and going. And the reason, okay, and I know this might not make super sense to us right now. The reason it happens that way is because if you found the very center of the circle, which is hard to do with just a person drawing a dot, it is an equal distance to the outside of the circle everywhere all the way around. And because it's an equal distance at every point on the circle, you could fold it anyway, as long as the sides are, matched up. I can't do this. This is not a line of symmetry. Y'all see what I just did? That's not a line of symmetry. Right here. But if my fold is going through the middle, where it should be, then I have a line of symmetry with the circle. So if you're asked, how many lines of symmetry does a circle have? Infinite. Okay? Does it have 30? Yeah. Does it have 50? Yeah. Does it have more than that? Does it have less than that? Does it have just 1 or 2? It has 1 or 2, but it has many more than that. Okay? All right, so just something kind of neat, interesting about the circle. As long as, though, your line of symmetry has to go through the center of the circle. Okay? All right? Because I could draw it there. I could draw it here and fold the circle. I could draw it here and fold the circle that way. I could draw it here and fold on that line. I could draw it here and fold on that line. I could draw it here and fold on that line. I could draw it, I could be here all day. Okay? All right. Would you set your circle into your stack of shapes? Okay? All right, so symmetry is kind of fun. It's kind of a neat thing to talk about, to look at, to look for. But it's not just in, like I said a minute ago, it's not just in plain old shapes. Okay? Even though it is there, it's not just there. There are regular, everyday things in our world that have symmetry. There are regular, everyday things in our world that don't have symmetry. Okay? So let's look at a few. Let's talk about a few. Actually, let me take a pause here. Okay? Let's see if you can find any in some everyday objects. Okay? Before we talk about it, because I don't want to get anything back. Okay. So you have a shape in front of you. Alright? Just turn around and shape, guys. You're kind of on your own right here. I just want to see what you come up with. So, now look at me. Look at me. Here's your reminder. Like if you have the flower, you're not going to go fold, fold again. It's one fold at a time. One fold, open it back up. Do both sides match. If they do, you can draw that line of symmetry. You have a question? Okay. We're not talking about them yet. Alright? So you're not folding it more than once at a time. Alright, so take a minute. See how many ways you can fold this shape so that both sides match. Both sides would need to lay right on top of each other and match. Okay? Some of you are going to be quick, and some of you are it's going to take a little longer. Okay. Draw that line of symmetry and find one. If you find one. And again, if you found one, don't stop there. Keep looking. But maybe one is all there is. Maybe there's more than one. Yeah, draw the line. Remember, you're only folding it once, one fold at a time. Give you about 30 more seconds. Just find one dog. Does that work?
It's hard to draw the line if you have it. He has a crazy head. It's Patrick. He has a crazy head. Patrick's complicated.
Okay,
Tell
so
me
let's
about
talk
it.
just a little bit. If you had the flower, now if you didn't, I still want you listening and watching, okay? Because there's things to learn from each other. If you had the flower, how many did you find? Not how many pieces, how many lines. Now, a line goes all the way through the whole thing. Okay? So how many lines of symmetry? Yeah. Like what? Did you cut it this way?
Yeah.
Okay. The tricky part with the flower is the inside parts have got to line up. Okay? Alright, so there is one right there. What other way did you cut it?
The opposite way.
Alright, going up and down. Okay. Now watch. Did I go diagonal with this? When I do that, I did it just a second ago. Where'd it go? It's not like the circle because certain folds across it, you see how the flower petals don't line up? So it's not like the circle where I can do it from any possible direction. I do have to line everything up. Okay, but we know it has at least 2, but I'm thinking it has a couple more. You can go diagonal with it. Try that. Okay. Who has the flower? Just 2 of you, 3 of you. Okay. I'm pretty sure you can go diagonal with it too. Okay. Who has the butterfly? All right. How many lines were in the butterfly? 1. Where is it?
You can only do that.
Just like if it had its wings together. But it was hard, wasn't it? You got to fold that little skinny body in half. You find it, Wendy? I got to take that little body and make it, and it's so skinny that it's hard to do. Make it look like a bee with a stinger, goodness. Okay, but right there is it's, when I open it up, there's the line of symmetry right there. Okay.
It's flapping.
Now it's ready to fly. Okay, what about the teddy bear? How many were there? Just 1. Where was it? Right down the center like the butterfly. Okay. Alright, could I do it top to bottom? No. Because the head and the feet down here are not going to be the same.
He don't have ears down there.
Right. You can tell by looking. I can't fold him from top to bottom. Are we symmetrical if you fold us from top to bottom? No, because I don't have a head down by my feet and I don't have feet up by my ears. Okay. Are we symmetrical a little bit? Which way would you fold us? Kind of
straight.
Yeah. Now, what if I have one leg longer than the other? Because I'm pretty sure if I measured, I would have one leg longer than the other. Am I perfectly symmetrical then?
No.
What if one of my ears is different than the other? You know? What if one of my eyes is, what if I have a green eye over here and a blue eye over here?
A black eye.
It happens. So we are kind of symmetrical, but we may not be 100% symmetrical. Okay. I want to leave the smiley face people out. Smiley face people, how many lines of symmetry did you have? Only 1. Could you fold the smiley face from top to bottom? No. Okay, let me borrow this. Okay, you can't do this because when I do, I've got a smile on one and a chin or a forehead. You know, think about our own face. Could we fold our own face top to bottom and have the same things match up? No. But could we go side to side? Yes. On this smiley face you could. You know, now if I was lopsided somewhere, then maybe not. You know, maybe I've got a big lump over here and not over here. But you know what? That's the beauty of it. If we're not 100% symmetrical, it's okay because that makes us all unique. I am leaving out the star, and I guess I didn't mean to, but I passed out all of my stars. Let me grab one from the other stack. Hold on. Now, what about the star? Okay, I need everybody's eyes. What about the star? How many lines of symmetry did you find? 5. You found 5. Any other numbers? What did you find? 2. What did you find? How many did you draw? One? How many? A bunch? Okay. So you only needed the ones that, we're not tracing every single line. Now there were 5. Because there are 5 points on this star. Okay, because this one's hard to do also because you've got to get that point folded in half and it's really skinny. So there is a line of symmetry. Y'all see that? Now open it up, both sides are the same. But look, watch what I can do with that star. Do it again. Open it up, both sides are the same. Do it again. Okay, so I was hoping, like, if you found that first one, some people will stop right there and go, oh yeah, it's got a line of symmetry right down the middle. Be careful, because some shapes, if you rotate them, they're the same as they are at the beginning. So if there's one right here, then there's also one right here. There's also one right here. Because every time I turn that star, it's in the same shape as when I started. Okay. So just something kind of fun, challenging. Let's look at these pictures. Look at the letter A. Now this is where you're going to have to do it mentally and not in your hands. Look at the letter A up here. Everything's out of your hands right now. Okay. Is that letter A symmetrical in any way? And if it is, how many ways do you think, how many lines of symmetry do you think are there? Okay, what do you think? You think 1. Anybody else agree with just 1? Okay, how would you fold it? And if you'll tell me, I'll draw it. What? In half which way? Like side to side? Bring the sides together? So my fold, that's what's funny. It's like I'm folding it side to side, but I'm going to draw my line up and down. Okay? Thought I saw something flying, but maybe not. Okay. All right, so again, my lines are not going to be perfect here. And they're really not going to be perfect because I don't have a pen that works. All right, but right here, if you folded it, bam, on that line, both sides of that A, do you see it now? And if you didn't see it before, it's like when somebody puts that line there, it's like, oh, I see it now, All right, the smiley face, we just did that, didn't we? How are we going to draw that one? Yeah. Okay, one fold this way. Because it doesn't have eyes on the top and the bottom, I can't fold it from top to bottom. You see, just like our own faces. What about a heart? Right here?
Side to side.
Same way, kind of like I've been doing these others. Okay, there's one there. Are there any others? Can you fold the heart any other way? Do you see it? Just got the one. Okay, what about the H? There's a lot of neat symmetry and geometry things with letters of the alphabet that people will want to use. Ishmael, what do you think? Side to side, like bring the sides together? We could do that. Okay, woo, my line really wiggled that time. But yes, I can do that. Are we done with the H? What else? Can I fold this one from top to bottom? Yes, you can. Here it is right here. I don't know. Maybe we can see it the same color. You have to cut that little skinny bar in half, but when you do, I can fold it from top to bottom. And the only difference there is that some fonts will make the top part shorter and the bottom part longer. If it were like that, we couldn't, but this one we can. All right, there's our star again. How many is this star going to have? Look at it carefully. Yeah, go ahead, everybody answer that one.
5.
Yeah, this is a 5-pointed star, so it's going to have one.
How many fingers that hand's on?
Here, 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 and here. Okay. It'll look like what Jayla traced a minute ago. Okay. All right. Look at the hand.
You couldn't do it if you didn't have a phone.
You think?
No, because you still couldn't do it.
No, because your fingers are different sizes.
Well, your pointer's like so little, and then your little finger like big.
Now, if we had two hands like this,
Well,
sure.
if we had two.
But we don't. So is there one there? No, because if I go top to bottom, I don't have fingers down here. If I go side to side, this is a thumb, this is a pinky. They don't match. Okay. All right. What about our butterfly then? It's gonna have the one, and we're gonna draw it just like we talked about. Straight. This is tough when that skinny little body. I can't laugh when I do that either. It would be bad. Okay. What's a lobster?
No.
You
can't.
You can do it.
Oh yeah.
At least once you can. Look at the butterfly and look at the lobster. You can do it the same way, can't you? Okay. I would have to do it this way.
Except the lobster has a big body.
And I could go with the way they've laid it. We would go top to bottom, and it would match. Okay, look at the arrow, like what you might see on a street sign right here. Do we see a line of symmetry on that one?
No.
Sure.
Yes. I have that like maybe one. You can. No. Grease it goes. You can.
Now I'm like Will. Sometimes I want it in my hands, just because I want us to try. Because I'm like maybe, but this one doesn't. It doesn't have one.
No.
You almost want to fold it kind of in half around the curve, sort of. But because the arrow, oh, I see what you're saying.
The arrow, you couldn't do it, but if it were just like, if the arrow wasn't there and it were like the other side, you could.
All right, let's move on to the car. What about the car?
Yes.
You
Yes.
can't.
The back is different size.
Is the back and the front of the car the same?
No.
No. They're not the same. This has a larger. Okay, listen though. This has a larger window. Now, if they had drawn it where it was exactly the same in the front and the back, if they had drawn it that way, then yes, we could. We could fold it in half side to side. But they haven't. This is a larger window, like the front windshield. This is a smaller window, and it may be hard to see back, where you are. The handle of the door is shifted to one side. It's not like in the center. So you're going to have a few little details that are not the same when you try to fold that together. Okay. All right. So this may actually be on the workbook page or very similar to it. And if it is, you'll fly through it because we've already done it. Okay. Now, this lesson goes a little bit longer in some ways because we're gonna do symmetry in some different ways here. Okay. So we have talked about it. We have folded and tried to create the line of symmetry by folding. But we're also going to try to create a line of symmetry by drawing it. Okay. This is not as easy as it looks at all. Okay. So let me make a few adjustments here. Okay. All right, y'all stand up at your desk, stretch a little bit while I'm passing Stretching, we're at our desk. You can talk to whoever you need to. All right. This. All right, go ahead and have a seat. Everybody's graph paper is slightly different because some of you have like the top of the page, some of you have the bottom of the page, and I cut them in half. So some of you have a few. Some of you have no graph paper at all, and you're gonna have to imagine it all in your head. It's the path I take around the room, and it goes around his desk. Okay, so you may not have exactly the same amount of boxes across and down, but I think everybody has plenty to do what we're doing. All right, I need you with me. We're going to stay together here and follow along. So have your pencil in your hand and your graph paper in front of you. Everybody has graph paper now, right? Okay. If you would, turn your graph paper tall like this. Okay, so that we can use two different areas. So we're going to start up high. Don't just start right in the middle. We're going to start up high. Okay. And I know my board looks different than your paper. We're going to kind of do this together. You know what? Hold on. Just hold on. Hold your horses. See, this is what I don't like about this. Okay, we're just going to totally change something. Take that graph paper and put it in the corner of your desk. You're not going to write on it at all. I'm going to come get it in just a second. And this is why, because right now, you're not really doing symmetry. You would just be copying the shape. Symmetry is where you kind of have something already and you're mirroring it. You're drawing the other half of it. So I want you to get out your workbook. Okay. And I want you to turn to page 64. 64, back of the book. Yeah, we don't even have to ask that anymore. That's where we are. Okay, 64, back of the book. And you will see some little pieces of graph paper on there. Now I know that it says homework at the top. That's on purpose. Because I'm going to let you do the problem set one on your own. We're going to do this one together. Okay? Now, I need you to not draw anything for just a second. I'm going to try to make, no, you know what? No, I do need to do this because this is different. All right, hold on. 1, 2, 3, 4. Alright, so is the first, I'm as crooked as I can be. Alright, hold on. Won't work. Okay, so is that what you see on the very first one? Okay, you should. Okay, we're on the page 64. This is what's already on the page, correct? Now it's on my page. Now get your pencil ready because what you're going to do, I'm going to draw it in red just so it's a different color. You are going to put the other half of that shape there. So that if it folded right there, there's not a line there, but I'm drawing it there. So that if we folded it right there, that would be its line of symmetry. Okay? So how many boxes up does this go?
4.
4. And how many boxes across is it? 2. And then it's 4 boxes back down. Now when you get to draw with grid paper, graph paper, let the boxes help you. That's why I counted them. Because I know, okay, I need your eyes up here and I need your pencil not moving while I'm talking. I know it went 4 boxes this way, so if I'm going to do a mirror image, I need to do 4 boxes this way. And I need to do 4 boxes this way. And I need to do 2 boxes across. You see how I just, so that if I folded it, it would match. All right, go ahead and do that with yours. Just that first one. You're doing exactly what I just did. You're not drawing anything real fast. Now, if you want to draw that line of symmetry there, that's fine. It's kind of already there at really light, isn't it?
Yeah, it's like a dotted line.
It's really, really hard to see this there. Okay. But it's got to match. So, if you didn't go down 4 boxes, yours is not going to match. If you didn't go across 2 boxes, it's not going to match. So that sure it's exactly the same size. Okay. Now, right now, this feels super simple. This gets harder depending on the figure they've asked you to draw. All right, so let's look at the next one. Let me set it up. Hold on. So you've got one that looks like this. It's 2 boxes, and then it's down 3. You're not drawing anything yet on this one. And then 1, 2, 3, 4, 5. And it has this little. Okay, is that what you have next? Okay. These with the slanted lines or a lot of turns and twists are not as easy. Okay? Hurry, go. Alright. Okay, get with me right here. Give me your eyes. How many boxes across is that top line?
2.
So 1, 2. Stop right there. The diagonal lines are what throw people off sometimes. So we're not going to do that first. Or next. We're going to do all of our straight lines. Brandon, we're looking up here. How many boxes across is this straight line?
4.
How many? 1, 2, 3, 4, 5. You can count it in your box. All right, we're going to go 5 boxes across. 1, 2, 3, 4, 5. See how those match so far? Now, one of the easiest things to do is just connect the 2 lines. Okay? That diagonal line goes across 3 boxes. Okay. Alright, go ahead and try the other 2 shapes. Now the one that has nothing but diagonal lines, count how many boxes it goes through. you're done drawing them, it should look exactly like a mirror image of the one that's there. You have to look. This one is 4 boxes high. Where did that go? 1, 2, 3, 4, 5 boxes. Too big. On that triangle, how many boxes high is it? It's 4 boxes high. 1, 2. So if it's 4 boxes high right here, 1, 2, 3, 4, then it needs to be 4 boxes high going the other direction. Okay. So use those boxes to count. It keeps you straight. It keeps you. Can't just guess with this. You've got to count. Okay. All right. I'm gonna give us about 1 more minute to finish those 2 shapes. All right. So even something as simple as a triangle, it's not as easy as it looks, is it? I mean, and look at, I don't know. Well, you'll see it in a minute. We'll have some fun with that one when we come back. All right, let's take a break because this is a longer lesson. There's just lots of parts to it. So you can put your pencil, write in your book, whatever. Go ahead and line up. We'll take a quick break and come back and do a few practice problems.